We are starting with a new lesson, triangles. For the first formative exam, you have the three lessons. One is linear equation in two variables, second is polynomials, and the third is lesson triangles. Now in this lesson triangles, we have to study some theorems. 5 theorems with proof we have to learn, and based on these theorems you will have to solve a rider, and one fill in the blank question comes in the exam. So in all, 3 marks for writing the proof of the theorem, 3 marks for a rider, and 1 mark for the objective question. So in total you have 7 marks. So let me start with the basics first, so that this is useful for later proving the theorems. Here we have a triangle ABC. A, B, C are the vertices of the triangle. These are the sides of the triangle AB, BC, AC. Now you know area of triangle is given by the formula half base multiplied by height. So let me explain this base and height properly, because it is needed later on in the proof of the theorem. Area of this triangle we will write as half, it is half base multiplied by half base multiplied by height. Now for this triangle, any side is the base. But once you take a side as the base, then the height is always the perpendicular distance from that opposite vertex to that base. So in this case, if I take BC as the base, then the height would be a perpendicular drawn from the opposite vertex to this base. Let us say here, let me draw just to explain to you properly. If I draw perpendicular to this base, then this length will be the height on this base, if this is the base B. So area of this triangle is half this base multiplied by height. I could have taken this as the base, then the perpendicular from vertex C to this base or the side would be the height. So in this case now, if I take BC as the base, then area of this triangle would be half BC multiplied by height. Let me say this point is D. Then half BC multiplied by AD. Let me take one more type of triangle, an obtuse angle triangle, where one of the angle is an obtuse angle. Say this is one triangle, and this, let us say this is triangle PQR. Now in this case, if I take QR as the base, then how can I write the area of this triangle PQR? If I take QR as the base, it will be half QR multiplied by the perpendicular to this side from the opposite vertex. Now can I draw perpendicular to this side from this opposite vertex? It cannot be done because it's an obtuse angle. See, if I draw it like this, it will be some obtuse angle. We cannot draw the perpendicular on this base inside the triangle, so I have to extend this slightly here, extend this line, and find the height of this triangle from this base. I will have to draw perpendicular outside the triangle. Let us say this is S. Then I can write area of this triangle PQR is half QR multiplied by this height PS. One more thing I require to prove that theorem, first theorem which I am going to explain to you later, is the one thing which we had learned last year about areas of triangle on the same base and between the same parallels. Let me draw two parallel lines. Suppose these are parallel lines, and let me draw one triangle here. Say ABC. Let me draw another triangle. Say here, let's take this as PBC. Then you can see that these two triangles are on the same base BC and they are between the same parallels. And what you had learned last year about such triangles on the same base and between same parallels, we had learned that their areas are equal. In this case, area of triangle ABC will be equal to area of triangle PBC. This we had learned last year and we have to use it this year. So now let us go to that basic proportionality theorem. An important theorem. It is in short called as BPT. So basic proportionality theorem. Also in short we call it as BPT. T stands for theorem. It is also known as Thale's theorem because Thale was a mathematician who proved this theorem. Now what does the theorem state? Let me draw and explain. If this is a triangle, say A, B, C, the theorem says that if I draw a line intersecting two sides of this triangle and parallel to the third side, if I join 2 points on these two sides such that this segment joining these 2 points is parallel to this third side, suppose this is PQ. So PQ is a segment which is intersecting these two sides AB and AC at P and Q. The theorem says that if this PQ is also parallel to BC, the third side, then these two parts and these two parts which we get as a result of this intersection of this segment on these two sides are having same ratio. This segment PQ, which is parallel to this side, will cut these two sides in the same ratio. Again, let me explain. See, because of this segment, this side is divided into two parts, AP and PB. And because of this segment, again, this side also is divided into two parts, AQ and QC. And if this happens that PQ is parallel to this, then as per the theorem, this ratio of these two parts formed on this side will be equal to the ratio of these two parts formed on this side. So theorem says that if PQ is parallel to BC, then AP upon PB will be equal to AQ upon QC. In fact, it is the theorem written here in the lesson triangles. theorem 6.1 theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This segment divides the other two sides in the same ratio. This is the BPT theorem. It is on page 104 in the 6th lesson, Triangles, theorem 6.1. So a big task now is to prove this theorem. So if it comes in the exam to prove the theorem, it will not be in the form, say, prove the basic proportionality theorem. No, it will be given the data. You will be given the figure triangle. You will be given the segment PQ parallel to BC. You will be given the requirements in order to prove that theorem. So let me write the way it comes in the board. But what we are doing is proving the basic proportionality theorem, which says that if this segment intersecting two sides of a triangle is parallel to the third side, then it divides these two sides in the same ratio. Then there are corollaries for this theorem, which I am going to later explain, because these corollaries will be used to solve numerical problems. So let me keep the diagram like this only. We will use this diagram. In the board exam, if it comes like this. Given, the data is given. See, in geometry now, something is given to be proved. They will first give you the data. Given in triangle ABC, points P and Q are on AB and BC respective, AB and AC, I think AC respectively, such that PQ is parallel to BC. This is the main thing. Then in order to prove this theorem, we require some more data, which they will give. They will give you a perpendicular like this on this, and they will give another perpendicular on this. Let us say this is a C and this is a D. They will also join this and give you C. Okay, here I have already written C, so let me take this as D and this as E. So that will be also given. You are given here QD is perpendicular to AB and PE is perpendicular to AC. And what you have to prove is, you know, as per the BPT, if this is parallel to this, then we have to prove AP upon PB is equal to AQ upon QC. So the proof. As you know, we write a proof. This is the first proof this year for you. We write a proof like this. We make a statement here and give the reason for that statement here. So using what is given, we go on writing some statements, and ultimately it culminates into this. So we are taking now triangle APQ and triangle QPB. Why do we take that? Those two triangles. because we have to get AP and PB. AP and PB. These we will take as the basis of these two triangles. So first step you must always remember, we always start with area of triangle APB upon area of triangle QPB. As we have already discussed this, area of triangle half base multiplied by height, area of triangle APQ, APQ upon area of triangle QPB. Half base multiplied by height. Now for this triangle, we will take this as the base. So half multiplied by AP multiplied by the height. Height means the perpendicular from the opposite vertex. In this case, it is QD divided by area of triangle QPB. We will take this PB as the height. So half multiplied by PB multiplied by height. Now I already explained in a obtuse angle triangle, the height means the perpendicular from the opposite vertex of this, perpendicular from the vertex opposite to this, which is Q. This height won't come here, it is already given here, QD. So the same height. You may write a reason for this. What we have done is based on area of triangle, we always used to take half base multiplied by height. You may write the reason here like this. Now if we continue here, let me write it again, because these are two different statements and I have also numbered them. So what I am doing is not going for shortcuts of writing equal and continue, but I am writing this again. Now you can see half up and down, you can cancel. QD up and down cancels. So what is left is AP upon PB from step 1. You may write from step 1. Now see what we have got is, we have written some ratio of two areas of two triangles and we got this left side here, AP upon PB already got. So I'll give you the outline of this proof. So then we will try to get AQ upon QC for some other ratio of areas of triangle. And then we are going to show that those areas of ratio of areas of triangle are same. So if the left side becomes same, the right side will also become same. AP upon PB will be equal to AQ upon QC. Now because, till I reach the bottom of this board, let me continue, then I'm going to write it over here, wiping this part. So now let us take, for getting AQ upon QC, go this side, but this side for this triangle we have to take AQ as the base, but with the triangle would be same as this APQ. So again we have to write APQ, but we will take AQ as the base for that triangle. But we need QC also as the base, but that base is for this triangle. There is a purpose why we are taking these triangles. So let's write the ratio of area of triangle, again APQ. Don't change the order of those vertices, because then we have to compare them. And upon area of triangle PQC. Area of triangle PQC. You might have a bit of trouble in visibility of this vertices. PQC. Now area of triangle APQ upon area of triangle PQC is, again we use the half base into height, area of triangle formula half. For this area we already written half AP, but this time we will not take AP as the base, but we will take AQ as the base. Half AQ multiplied by, now on this base which is a perpendicular, PE upon half area of triangle PQC. We are taking QC as the base. Half QC multiplied by height. Height on this base, this is again obtuse angle triangle. So its height won't come this way, but it's already given here outside the triangle PE. So PE. Now again here you see half common, same P, same common factors can be cancelled, and what's left is the fourth step. I'm repeating. I tempted to go for shortcut, but no. I want you to write all these things again so that it becomes easy for you also to remember the proof. Half cancel, P cancel. So what's left is AQ upon QC from step 3. This is, if you want, you may write. I don't think there are marks for these reasons because that's not so important reasons. Area of triangle APQ upon area of triangle PQC is AQ upon QC, which we wanted here. See, in order to show this equal, in order to show these two equal, we have to show these two equal. If these two are, we can show as equal, then this right hand side will be also equal. If left hand side are equal, right hand side are equal. In this left hand side, you can easily see that the numerator is the same. APQ. Numerator is the same. So if can show that the denominators are also same, so this both will become equal. Left hand side will be equal. Now how to make the show that these denominators are equal? What is this denominator? QPB, this triangle. This triangle. See, this is parallel to this and this triangle. See, this triangle vertex is on this BC. And PQC. See, this triangle vertex is on this base, on this BC. And you know that these two are parallel. These two are parallel. And these two triangles are on the same base PQ. Same base PQ and between the same two parallel lines. So what do you know about this? Such triangles which are on the same base and between the same parallels. I just not explained before I start with this proof that 9th standard we had learned that if the two triangles are having same base and if they are between same parallels, then the areas are equal. That means these areas